Hello everyone, welcome to the second part of this tutorial. We are in Maya creating moss with the MegaScan assets. So in this part we are going to work with Mesh to create some moss patches. This is the next part of the workflow. As you know, in the Quixel MegaScans that I led before, you go right down to the final scene, but we won't do it like that. And the reason is because if we went to some reference here, if you find the mouse, it has this particular shape. As you see, the mouse shape, it has this kind of dome shape, and this is very unique and very regular in all the moss outliners on contour. As you see in here, different type of moss grow in this dome type shape. So there are really different type of shapes. For example, this one, as you see, are kind of small shapes, but I believe they have the same principle of dome shape. Look at this, it's pretty obvious that it's growing in this kind of outliner form. So this is what are we going to try to recreate in the software before going to the final scene. And I believe this is gonna really make a difference if you are making something like grass or any other small creation, a live creation, because as you see, this really get apart from how the grass grow, this type of dome shapes. And as I said before, if we go from here to the final scene, we will end something more like grass. But now, as we understand that we need to generate those shapes before, we will need to have some bases, some places where to get a kind of a patch. So at this point we are gonna generate some moss patches, and I want to get back here to Quixel Bridge in a second and show you a few references that I really like and I want to talk about. Okay, here as you see, these are exactly moss patches. So the difference with this and the ones that are we going to create is that this is flat image and we are gonna generate it with the cards which are growing perpendicular from the surface. So this is another type of result. But why are we watching this image? Because as you see, its outliners has kind of different type of shapes. If we look at them and think on them like primitive shapes, they will be really different from each other. So for example, these on the side are more like rectangles. It's kind of a big rectangle, and the lower it's kind of a rectangle but with triangle, and this is more like a circle, and this is a real triangle, almost symmetric triangle. So there are a few laws that we want to follow at this point, because if we generate only one patch as an outliner form, this will be pretty obvious when we generate the final scatter. So there is a law who says that if you have 3 or more different objects, for the viewer to recognize that are repetition in those objects, it's gonna be more difficult. If there are 2, there's gonna be visible the repetition. If it's 1, it's gonna be pretty obvious the repetition. So if they are 3 or more shapes, for the eyes are gonna start to really blend these models that we are generating. So at this point, I believe that these 4 models for our patches are gonna be really nice to work with. And so if we go to Maya, we will try to generate these outliners before start the scatters. So I talked to you about this part because in the first version that I made from my mouse, I made it with only one outliner, that was the circular, and like you have to make these small shots, really close shots, the repetition of the circular model was pretty obvious. So at this point we go to Maya again and try to think on how we are going to generate those outliner forms, but also thinking that we want the dome shape. So as you see, first I'm gonna create an sphere, thinking that this is kind of a circular outliner. And I'm going to assign in the subdivisions about 60 subdivisions. And the other thing is the dimension. The original patches that I made for the scene that I showed you in the first tutorial was with the base of the patches with a dimension of 1 centimeter. So this dimension will really help us to work with small branches or a kind of places who has really small radius. So the dimension of the base, it's gonna be of 1 centimeter. And I'm going just to grab one edge loop or face loop, sorry, and think that this is going to be our end dome shape. I'm going to isolate it. And if we think that the center of the grid is the center or the ground point where mesh are gonna interpret, we are going to put the outliner of our dome shape as the base or the ground of the form. As you see, we are trying to replicate this kind of form and relation with the ground. So try to get exact or kind of similar shape. And if we think this is going to be our kind of start point or base to work and try to recreate the other forms. So for the second, which is the rectangle, I am just going to generate a plane, and with the other dimensions try to get something similar to the original, and with these subdivisions we are working fine. I'm going to generate kind of these holes, but in the middle of the patch. So if you see it, it is kind of round in the end corners. So we extend that, and to get better smooth, we just extrude in here. And okay, this is the result. And now we are going to try to get the dimensions. So first confirm the dimension of the original dome. As you see, the grid is of 1 centimeter, so I'm just confirm the dimensions with the grid and get back to the center. And here I forgot to, okay, here we have the dimensions that we need. And now I'm going to go in the outliner, select these two last created, and in the top view we can really confirm if we are getting the outliner shape. So the point in here is try to get a projection of the shape in top to the dome shape that we made. So I'm just confirming with subdivisions, and as I said, in top view to really have the outliner of the same shape. Now I am going to make this object alive. As you see with the dark green, it's alive. And now select the top with the y-axis and just drag. It will snap to the alive object, and I turn off the alive object and drag it a bit to view how it's the shape. And here the point is that with the subdivisions the top shape end with a similar area to the bottom one. So to create a similar dimensional shape but with a different outliner. Here I'm just checking the height and the base that are at the same place, and I believe that maybe this can be already our second version. So I'm going to drag it to the side, and for the third version we just need maybe to deform the shape that we already have. So we are going to back, and I believe that we can use the FF modifier, FFD, sorry, and put it 2 and 3 in this side. As you see, and working inside the lattice mode of the FFD. Here to view both shapes, the previous and the one deformed. So I'm going to turn off the FFD and duplicate, and then turn it on again with this envelope. And now keep on working on the new shape. I'm going to make it maybe a bit asymmetric. Here in the reference, as you see, it's really going to a side, but for the base, for the patches, we need just a small deformation. So I believe that this is the third already. And now for the triangle, we generate again a sphere, and in this time we are going to assign it 3 in the subdivisions of the axis and 10 in the height, and we're going to let only the 4 top, and again try to work to get a similar shape to make before the projection. As you see, I have a lot of tools with shortcuts. I don't use the shelf or any other button to get the tools. For me it's faster to work with my shortcuts. So here I just make again the bottom alive and project the triangle inside it. And here I am going to try to get again the triangle shape a bit inside the projection. the spherical projection. Okay, and this also we view it with tree, so we are gonna make subdivisions for this. And okay, here it's the result of this shape. And again we're going to try to get the same area for this one, and try to that the dimensions are the same. So I'm going to confirm the dimensions here with the 1 centimeter. And okay, I believe that they are working already. So here we have our basis to generate the patches. So at this point we are almost ready to work with mesh. But before start working with mesh, I'm going to explain other thing that I made to get a bigger variation. I view this is kind of bad. So I'm going to snap the pivot and then snap it to the grid and try to get the same height. As you see, all of them have almost the same dome shape in their height, and they are growing from the same point also. Now I delete the history and fringe transforms to they understand they are in their 0 position. And this tree I'm going to assign a smooth, but with the settings, so I can assign them already 3 subdivisions. The point here is that they end with similar kind of detail or amount of polygons. It's not necessary to be exactly the same, but we are going to use a texture modifier, so we need some vertices to deform the geometry. So as I said, the next step is to generate a second point deformation. Okay, I'm going to back to our reference to show you how we need to create a second point of deformation. As you see, these dome shapes has a kind of fractal type of grow fashion, fractal fashion. And as you see here, we have a big dome and it contains small domes. So here, small domes and bigger domes. So this fractal kind of fashion, it's really key on the mouse creation. So it happens really regular in different examples. For example, this, as you see here, are a big model. This one is really big and contains smaller models like this one, and here it's a small model, and we will see how this dome configuration within fractal fashion, it repeats all the way within the mouse creation. So what we need to do to mimic that fashion, it's going to create some texture deformer, and that it's going to be made with some procedural deformers. So I'm going to create a volume noise, and this volume noise already, if we go to the toggle size and view it, this below section or this below fashion, it has already this type of spheres, or if we are going to view it with a plane, it's going to be dome fashion. So this already it's going to work really nice for what we need, but as you see, the actual density, it's really low. So if I play a bit with the settings and just change some of them, we will have something similar to our reference, but as I said, in a lower density. So what are we going to need? It's to duplicate this original to give the actual density that has our reference. So if we create the copies and then use this time slider, you will see how the points change from the actual place. So the copies, we can just change this time factor and we will have a different points for the actual point or the actual domes at this case. So I want to show you the actual rig that I made at this point and try to explain you the different factors that I made to generate the final map deformation. So here it's, as I said, a volume noise, and it's in below and is in fast. These are the main characteristics, and 20 in the scale. And as you see, all four have those settings: 2 in depth max, 2 in frequency radius. So they are almost the same, but what must change is this time factor. So as you see, I have controlled the time with something inside. So what is inside the time factor are this multiplier divide, and this multiplier divide has in the output 2, 4, 6, 8, 10, and they are controlling the actual time in each volume noise. So if I go in the input and put this remap value in the input in all the inputs, I will control the factorial multiplication of the equation within only one node. So with this node, if I go to 1, I will have 4, for example, in this, because the second output is 4. So if I go and type 2 in here, I will end with 8, because 2 by 8, 2 by 4, 8, sorry. So this node will end controlling all the time factors in our final deformation texture deformer. So I just create some layer textures, and these textures are in add mode, and as you see, it's just one in none, the second in add, and then I create other volume noise with the purling noise with almost the same scale and other things, and also the multiplier divide controlling the time, and this added to other layer texture in illuminate mode. So as you see, the third it's in illuminate mode, and the others are in add mode. So this is our final layer texture, and I put it the name to Geo to know that this is going to deform our bases. And okay, I hope it was clear how I create that. And now I'm just going to make a group for these small bases, and I want to duplicate them to make size variations. So I'm going to make the group and give it a name, maybe small size, and I'm just going to duplicate and give it to this and a scale of 1.5. And in the scene that I show you, I use these three different size, and they are going to work with different things. So if you are going to make moss in small branches, you are going to use the small size. If you are going to make a scatter in a trunk, maybe use the middle size. And if you are going to make in the floor or something that it's really flat, create it with this big size. And as you see, I put it 3, but in the future I'm going to put in 2.5, which was the actual size that I use in the scene. So here we have already our different bases to assign the texture modifier and have our last transformation for the bases to start building the scatters. Going to grab the small ones, and go to the deforms and again a texture deformer. And as you see, this texture deformer has to be in point space in the normal directions with a strength of 0.5 and this offset of minus 2.5. The envelope will change it as we view the effect. And if I grab one of the bases and just search for the texture deformer in the attribute editor, I will going to drag with middle click this final layered texture and assign it in the texture section. And as you see, instantly we have this second level of deformation in our bases. And at this point of size, it's not really evident how the fractal fashion is working, but as we assign it to the other size, you will view how nice it's the map working within this fashion of domes inside domes. So I'm just going to show you also how this remap value are going to change our deformations. So when we change from one type of moss to other, we can change also the form of the base that is generating our patches. So when we create a new type, we're just going to change also this factor and the base is going to have a different shape. And obviously it's pretty subtle, but all of these subtle deformations and changes are who really is going to give us a natural feeling to the final scatter. So I'm just going to grab the other size and type G to assign the last tool, which is our texture deformer, and again assign it. And now the big ones, select them, G, and drag again with middle click the layer texture. And now at this point you will be able to see really nice how the different models of deformation is working inside the base. So as you see, we have this dome shape, as I said, in small factors, and we have the kind of fractal fashion growing different models of domes. So this is really key. And also check how if I change our output max, it's going to change all the time factors in the volume noise, and it's going to change the effect of the texture deformer. And this is going to be key when we are creating the different type of moss. So we already have a nice rig to start building the patches and have them with different shapes. And I'm changing now the intensity for the small ones with this envelope, and now to the mid sides a bit also, and if the big I feel it's too much, also a bit. But as you see, this one has the most impact, and the mid-size a bit less, and the small ones also a bit less. So now we have our nice rig ready. We have to give a start point, maybe obviously in 1, and now we have to give all the surface a new names. As I said before, I'm going to change from 3 to 2.5. And the good thing of using 3D volume noise is that this scale won't affect the actual size of the noise. So if you see in here, we have this big ball in this point, and if we are using a 2D texture, that ball will just scale with the actual form. But if we scale in here, we check that the ball stays where it was. So that's the good thing of the 3D textures, which doesn't depend on the scale and the UV coordinates, and are pretty nice to deform things in the world. So now, with this already done, I'm just going to move it from the center of the world, and before start our scatter, we will have to assign them new names, because mesh, as we are going to create the scatter inside this geometry, mesh will have problems to know which is one, as they all have the same name. So I'm just going to grab the small ones, and within rename tool, just going to put base and put it an S in the middle to know that is our small bases. So S and B for the variation, and it will assign all the numbers. So base M and UB, enter. And the big ones, base B, big, and UB, enter. And okay, I put this big size, forgot. And finally, we have our setup ready. We have the outliner of the bases with different shapes, and also a procedural deformation for the inside deformations and the dome shapes. So these are the key factors that are going to give us a nice natural feeling for the final scatter. So I'm just going to grab our original moss group and grab the first group. So I also have the groups in the same types. So the first one is the big ones, and the second ones are the small ones. So for now, I'm just going to create for the long ones. So select each geometry individually, not the group, only the geometry. And go to the mesh section, which is in effects or in animation. And I'm going to create a mesh network in the settings. And it will pop up, in theory, this window. And the third thing is to as well give it some good naming conventions. So as you see, I have this 3BP2, and the reason I have that is because if I go to bridge, right click to open the folder, you will see that the final letters in this extension are 3BP2. So I also use this to know that I'm using this card in the future, and because if you have more than one card of mouse, then you will have to know which is one and those things. So these final letters are really helpful to know which asset are you using from the MegaScans. So I'm going to give it in the geometry type this mesh reproduction, and in the distribution we are going to leave it like that. It doesn't matter for now. So when we hit apply, we will end with this array of one of our selections, and we will find it was our first selection. So we'll need to go to the mesh editor, and in the mesh editor we will have these two first nodes, and this will be like a master, and this is our first attribute that have our mesh. So as you see, it will create a distribute node or distribute section, and this distribute is going to be how the scatter is going to be generated in first time. So we have different types like radial, grid, spherical, but at this point we're going to need the mesh. So I'm not going to click it in mesh, because if we go to the mesh section in here and just in the outliner we search for our first base and click in the distribute node to view it in the attribute editor, with middle click you will drag from the outliner to the input mesh section, and instantly when you leave it, it will change the distribution type to mesh. And as you see, it's generating now our scatter in the first base, and it's generating 10 points because we have 10 objects in the original selection. So now we need to change some settings from this distribute node, and one really important thing is this use face, scatter use face area. So if you check these geometries, we will have different density of points. So normally Mesh will understand that when are more density of points, will grow more actual things from there. So if we use this scatter uses face area, will distribute the actual scatter in the area of the surface and will not depend on the density of the vertices. So to have a really nice distribution or even distribution, you will need to have that checked. And now, as I said before, we'll need to add the ID. You can make it from here or from this plus icon, and I really like more from the plus icon. So I'm just going to add it an ID node, and when it's done, you will see that our 10 nodes of repetition are now our 10 different selection. So to keep from here, maybe it's better to view it with a bigger amount of repetitions. So in the distribute node, I'm going to change in the number of points to 100. And now you will be able to see that we are getting this dome shape. And it's because it's calculating the normals of the surface. So as you see, this calculate rotation gives us already the normal direction of the surface to our creation. So with these two checkbox, the scatter use face area and calculate rotation, will give us the result that we want at this point. So here, as you see, we will have to add other node to have some random transformations. To do that, we will have to add other to the stack. So to have random transformations, we have this random node. And this is really similar to what can we have in forest pack inside 3ds Max. So with the random assign, it will give us already by default some position transformation, which I don't want. So I'm going to put it 0 on the position transformation, and then I'm going to assign some random rotation. 2 in the x-axis, 360 in y to rotate in their own axis, and 2 on z-axis. And I put these small numbers on x and z because if we go to our reference, you will see that this moss really grows pretty straight from the actual direction of the normals. So that's why we use these small numbers of transformation, of rotation, and also give it a bit of scale to also have a more natural feeling. I will uncheck this absolute scale, so it will scale also in the negative direction, It's up to you if you leave it or not, but this transform space, it's really necessary to work in local space, so these transformations will work in each local space of the mouse. So now we have this really nice dome shape and also some nice random transformation for our node. Now if we go and check the actual density at this point, we are gonna check that we have these big holes. So to fix those holes, we will need to add more points. So if we go from 100 to 400, you will see that now it's really dense, and also we will see really nice that dome shape that we want to create. So at this point we are really close to end our patches or the main deformations that we need to create for the patches, but we also need to view our image to understand the next step. So at this point I make some renders with these iterations, and I found some issues in my final image. So here I'm going to show you like the process. So in this top are the original cards, and I made these scatters like the way of the Quixel tutorial, so they are pretty flat and pretty straight. And if we scroll a bit, we will find that we have this type of configuration, this type of result that we see in here. So as you see, is the patch, the actual patch that we have right now, but on the side we see the actual card again, and again it's pretty flat, even that we deform it and rotate it and bend it, it's already looking also a bit flat. So to solve this part, we will need to add a new level of deformation to the patches. So to do that, we will need again to create a texture deformer, and as I said before, the best way is to create a volume noise. So I'm just going to go here in the hypershade and create a new volume noise. And for this one, I'm going to show you something that I didn't show you before, and it's how I set up the volume noise to work in the word and to view it and know how it's deforming the actual word. So I'm just going to change some of the settings in here before going to the word. These settings I know that are going to work for what are we going to do. and it has to be a purling noise. Okay, so the way to do it, it's almost like the card. You just create a Lambert material and assign the volume noise to the color with middle click again, and I'm going to create a plane who has similar dimensions to our patches. So if I assign the material to the plane, I can view by isolating this object and make viewable the texture, I view how it's ending the volume noise and the dimensions in the world. So if I go and change this here, I know how it's affecting, at least in size, the world. So I'm going to leave the settings as I said before, and the key point for this deformer, it's going to have a different value on the y-axis. So I'm going to rotate it 90 degrees to view it within the y projection, and I'm going to select the 3D controller for this noise. So I'm going to open the hypershade and select this node, which is the 3D placer texture, and add it to our viewport. And as you see, if I select this and transform it, it will transform the actual texture in our plane. So what I want to do, as I said before, it's let the y-axis with a different value to have more intensity on that axis, on that transform deformation. So now I'm just going to turn off the viewport viewing and turn off the isolated selection, and just going to assign a deformer, a texture deformer for this patch. And the settings can be the same as the last time, but we change the envelope maybe to 0.7 and just hit create. So if we open the hypershade and maybe give it also a name to this, maybe Tumos, we can go to the attribute editor again in the texture deformer and assign it with middle click to the texture, and this it's going to give us our final deformation point to really break the light on the actual patch. So as you see, this gives us some random deformation, some noise deformation, and it's going to be really key to break the geometry and also break the light when it hits the surface. So here, as you see, it is bending in and giving it some random things. So when we render it, we will have a really nice result and natural feeling to the geometry. So finally, we have all the deformations and all the forms and shape that we need at this point to take this to a final scene, to a render scene. So I'm going to duplicate this patch, center the pivot, and delete the history. Put it to the side, and as you see, we have our first final result. So at this point, the next step is pretty easy. You just go into the distribute node and start to change the base in the input mesh. And as you see, instantly mesh will understand our new shape, and with these random seeds on the distribute node we can give a different shape, and also we will have some random seeds on the random node. And at this point I like to have a similar shape from our base. So the first is going to will have the triangular shape, and the second must the circular shape, and the third the rectangular shape. And as you see, if we play a bit with the random seeds inside each version, we will have a lot of end results. So I'm just going to tell you that you will need some different amount of repetitions when you change the size. So you go for each base, duplicate the end result, and just go to the next base. So when you change the size, as I said before, you will need to assign a new number of points. And at this point, to almost all the type of moss, I use in the small one one number, in the middle one the double, and in the third one almost the double of the second. So these are 400, 800, and 1500. So here, as you see, if we check the base of our scatters, the place where they are going to grow in the smalls are really small, and in the others are really much bigger. So that's why the small ones are going to work really well for branches, and the other maybe won't. So at this point I'm just going to also assign one of the outputs to the deformer. So when we change the type of moss, we'll also change the deformation inside. So I'm just going to grab one of the outputs put it in the time. And as you see, now we have also control the deformation of the moss within our random seeds. So when we create the other type of moss, it will change the deformation inside it. So, well, these are all the little things that at least I used to give it some random feeling, some natural feeling to the image, and natural feeling to the final scatter. Before we go to the final scene, we have to well, organize all the end result, and I will show you how I made the groups and the organization for the next step. So here it's the group of all the types of moss within the card. So here it's the first 12 that we made. So these are the smalls, the mid size, and the big size, and then the other type of moss, as I said. And well, the end result is this garden type of thing that will help us in the final amount of repetition in the scatter, and also will give us some nice shapes. And other thing, it's the density. As you see, for example, these are the leaves, and it has a pretty low count in the density. And this, it's the lichen, which, as I said before, it's flat on the ground, so it grows different, and it also has a lower density on the scatter. So depend on the type of moss, you will have a much more dense scatter for the patches, or a not so dense. So at this point that we let our geometries, we need to fix them the pivot. As you know, before we already center the pivot to the geometry, but we need to center the pivot in the y-axis to the word, so Mesh will know that this is their point where they are going to grow. So I'm going to select each one, and just by selecting the y-axis and with the pivot transformation, just going to hold X and snap it to the center of the grid only in the y-axis. As you see here, we let the other two axes alone, and we just snap the y. So I'm going to repeat this process, select the other, and with middle click just drag the y-axis. For the bottom one, again drag it the middle click. And okay, these guys are really ready now to work with mesh when we are going to work in the final scene. So, as I said before, it's important to make some naming conventions, not only for the type of mouse, but also for the size. So as you see, I let this S for the small ones, this M for the mid size, and this B for the big ones, to also know which I am using when all are going to be in the center of the word. Just as the cards, when we use mesh, we will need to send all these copies, all these patches, to the center of the word. So what I like to do now is make an actual copy of this group, because I like to view it like within this organization, so I can select them or replace it if I need something to be replaced. It's easier to have organized at this point. So I'm just going to grab the whole group and duplicate this. Okay, here as you see we have the copy or the duplicate, and I'm going to hide the originals, and the same process with the cards. Select all individually. I'm going to view that the pivot is on the center, and with middle click while holding X, just drag everything to the center. And finally we have this all together in the center of the word, and we can use it on a final scene render. And well, I'm going to suggest to make proxies at this point. I'm going to let you some videos and links if you work in Arnold to make the proxies for Arnold, and also if you work in V-Ray. So you just make the actual proxies of each patch, and those proxies are the ones that we are going to use on the final scene. So well, to recap, up to this point we start with the basis and create these 4 different shapes to have a different outliners. We make different size of them to have different size on the final patches, and then we create a volume noise and mix them different type of volume noise to have an intern deformation for the patches. So we create a type of rig to control the volume noise and the deformations to make the different type of mouse. Then we start building our first patches, and those patches we assign them a texture deformer. That texture deformer in this final patches group, and we move the pivots in the y-axis to make them grow from their actual center. We duplicate the group together to snap it to the center of the word, and at this point it's where you can just build the proxies from your own render software and send it to the final scene. So I'm going to leave this video up to here. I'm going to thank you for watching, and well, like it if you like it, dislike it if you dislike it, and I'm going to try to upload the third part as soon as possible, which is going to be in the final scene, and to know how I made with Mesh the final scatters for that scene. So I hope I see you there, guys, and again, thanks for watching.